Okay, so how do you think we should approach this problem mathematically rather than just rolling dice?
Well, so we could just write down some probabilities that we have. We know one die has a 1/6 chance of rolling a 6 every time.
Okay.
So we could maybe do some cases, and like it would be a lot of cases, but
Sure.
soon pretty quickly the cases would have such small probabilities that they become pretty much irrelevant.
Well, maybe. Let's see. Let's see. What's the first case you want to take a look at?
So we just roll a 6 on the first one.
Okay. So
That's a 1/6.
one try is 1/6. Okay.
Maybe we do 2 tries.
2 tries is 1/6 times, or 5/6 times 1/6. That's 5/36.
Yep. And then 5/6 times 5/6 times 1/6. Because we can roll the same numbers.
Okay.
And then this is gonna keep going.
So 5/6 times 5/6 times 5/6 times 1/6.
This is the probability of getting it on the fourth
Fourth. roll.
try without having gotten 6 previously.
Yes.
Okay, nice. So now here's the challenge. What sum are we going to have to write down to figure out the average roll where we got, or the expected roll that we got?
Well, what we can do is we can factor a 1/6 out of our sum, and we can write it as 1/6 times the quantity, 5/6 plus 5/6 squared plus 5/6 cubed, all the way up.
Yeah, unfortunately though, that is going to tell us the sum of the probabilities for getting it on the first one, getting it on the second one, getting it on the third one, getting it on the fourth
So
one.
that's going to sum up to 1.
Add up to 1.
So that sum is going to add up to 1. And that is not the sum we're looking for, because that is an important sum. That's the sum of the probabilities.
Yeah.
And that just tells us that we're going to roll a 6 eventually.
Right, that'll tell us that we'll roll a 6 eventually. But what we're trying to find is the number, the expected number of rolls that it takes. So how can we use the probabilities to get to the expected number of rolls?
Using the probabilities to the expected number of rolls. We can multiply the number by the probability.
Okay, so now I would have 1 times 1/6, 2 times 5/6 times 1/6, 3 times 5/6 times 5/6 times 1/6, 4 times 5/6 times 5/6 times 5/6 times 1/6, etc. Now what is this? What are these individual numbers telling us?
So that's
Kind of a challenging question.
each individual number, and it's, you multiplied where you got it, like what roll, by the probability.
Yeah.
So I don't know what each individual number would be telling you.
It's sort of a weighting, like we're doing in an average. When we do our average, we expect a 1 to come up about 1/6 of the time.
Yeah.
We expect a 2 to come up about 5/36 of the time. We expect a 3 to come up about 25/2/16.
Yep.
So this is telling us, this is sort of giving how many 1s do we have, how many 2s do we have, how many 3s do we have, how many 4s, and etc. And once we know that, what's that infinite sum going to tell us?
Oh, it's going to tell us how many of each we have. Or like what the total number is.
Okay, and what is that number, total number, going to represent?
That's going to represent our average.
That's going to be the average. So we have a fairly tricky sum we have to evaluate here. to get the average. It's going to be 1 times 1/6 plus 2 times 5/6 times 1/6 plus 3 times 5/6 times 5/6 times 1/6 plus dot dot dot. I guess I'm going to run out of room. Okay. So in the next video, let's see if we can figure out some strategies for how we might add this infinite series.
All right.